Okay, let's take a look at this quiz 5.1 to 5.3 review sheet. Remember, I told you the first 14 questions are going to be matching, so I expect you to be able to identify the special segments and their names, the intersection of those special segments, along with a couple of other definitions. The way I always handle matching is to read the definition first, then look through my choices and make my selection. First one says the point of intersection of the three medians. So the medians, remember, are those points that, or those segments that connect a midpoint with a vertice. So that means that those are all going to intersect in every triangle on the inside. So the intersection of the three medians of a triangle is called the centroid. Centroid is K in this case. So, and cross out the ones you've used. Each one will be used only once, so you won't have to worry about using two. There's no tricks, there's no extras, there's one for each. Number 2 says the line that goes through a vertex and is perpendicular to the opposite side. That would be the altitude, G. So I'll put a G there. Number 3, a ray that divides an angle into two congruent angles is an angle bisector. So I look through the list, I see that E is an angle bisector. Number 4, a segment that connects the midpoints of two sides of a triangle. So that would mean that if it connects the midpoints, it's the mid segment. So I'm looking down through my list to see if I can find the mid segment of the triangle. It looks like I have to scroll down because I'm not seeing it there. Oh, there it is. N would be the mid segment. So I'm going to put in N in for number 4. Number 5, a segment that connects a vertex and the midpoint opposite. If it connects the vertex and the midpoint opposite, it's the median, which is M. The longest side of a right triangle, longest side of a right triangle is the hypotenuse, H. So I'll put an H here. Number 7, a segment that is perpendicular to and bisects a side. That means that would be the perpendicular bisector, I. Put that here. Number 8, the point of intersection of the three perpendicular bisectors is called the circumcenter. That's F. Number 9, the place where 3 or more lines intersect is called the point of concurrency. That's up here at the top, A. So I'll cross that out and put an A in number 9. Number 10, the congruent sides of an isosceles triangle are called legs, L. Number 11, the point on a segment that is equal distance from the two endpoints of that segment is called the midpoint. Midpoint is D. The point of intersection of the altitudes of a triangle is called the orthocenter. That's B, the orthocenter. Number 13, the point of intersection of the three angle bisectors is called the incenter. The incenter is C. And finally, the last one, the non-congruent side of an isosceles triangle is called the base, J. Okay, you'll see they won't be in the same order. They won't probably have the same number or letter attached, but those are the definitions you should expect to see tomorrow on the quiz. Next problem, you're given this triangle. You're told that DE is the mid-segment of AB, FG is the mid-segment of triangle DBAE, and HI is the mid-segment of triangle FBG. So what that means, DE is the mid-segment of triangle ABC, so that means that DE is equal to 1/2 of AC. FG is the midsegment of triangle DBE, so that means that FG is equal to 1/2 of DE. And finally, HI is the midsegment of triangle FBG, which means that HI is equal to 1/2 of FG. And after you've established that the midsegment is equal to 1/2 the length of that third side, it becomes a lot simpler to find the lengths of the segments you're looking for. So now you're looking to find FG. FG, HI is equal to 7/2. So if HI is equal to 7/2, what is FG equal to? So you just multiply both sides by 2. Okay, those 2's will cancel. The 2 and the 1/2 will cancel. These 2 will cancel. So FG is equal to 7. FG is equal to 7. Then you know that DE, you're looking for DE. So FG is equal to 1/2 DE. FG is 7. That means DE is 14. DE is 14. And now you know that DE is equal to 1/2 of AC. So in order to find AC, you just double DE, and that becomes 28. Okay, the secret there is that the midsegment is 1/2 the length of the third side. Now number 16, you're given the perimeter of SOP. So you're given the perimeter of this whole triangle. But you are given the lengths of the midsegments. Okay, so clearly the lengths of the midsegments wouldn't be equal to the perimeter. So all you have to do is double the length of the midsegment. So the perimeter of SOP, which is 274, is equal to 2 times x plus 4, the length of this midsegment, plus 2 times the length of this, which is 3x plus 1, and the length of this, so plus 2 times 5x minus 3. So you have 274 is equal to 2x plus 8 plus 6x plus 2 plus 10x minus 6. When you collect up all those like terms, you have 274 is equal to 18x plus 4. Subtract the 4 from both sides, you're going to get 18x equals 270, so x equals 15. The other way you could look at this, so this is a second way you could think of this, is you could actually take the perimeter and divide that by 2, and then set that equal to the midsegments, and you'll get the same answer because it's a linear measure. Okay, number 17 says you are given D is the perpendicular bisector of OG. So I have this segment OG. I have the perpendicular bisector right here. And it says D is on that perpendicular bisector. So it's anywhere on here. And then you're given that OG, or excuse me, DO, this is D, so this is DO, is 2x plus 1, and then that DG is x plus 28. Well, if D is on the perpendicular bisector, then it means that D is equal distance from O as it is from G, which gives you 2 congruent lengths. Remember I said if it's on the perpendicular bisector, you're going to get a lot of isosceles triangles any point on that perpendicular bisector. Therefore, 2x plus 1 is equal to x plus 28. Subtract the x from both sides. we get x plus 1 equals 28, and then subtract the 1 from both sides, you're going to get x is equal to 27. X is equal to 27. Substitute that back in. So DO is equal to 55. Okay? Next question, number 18. This is the distance from a point to a line, and the graph's here just to help you visually look at it. If I have a point at -1, that's right here. If I want to plot this line, I'm going to put it in slope-intercept form. You don't have to, but it may help you visually see this. Y is equal to -3/4 x plus 2. So I have this line, crosses the y-axis at 2, has a slope of -3, 4. So here is the line, and that's the point. Remember, we said we can go through the very long involved process to find this distance, or we can use the formula, the distance is equal to the absolute value of ax plus by plus c all over the square root of a squared plus b squared. Remembering that I have to subtract all the terms over to one side so it's equal to 0. That means I have a point at -1, -1, and my equation would be 3x plus 4y minus 8 equals 0. So my x is going to be -1. My y is going to be -1. My a is 3. My b is 4. My c is -8. So I've identified all of the values of those variables. Now I just have to substitute it in. So the distance is equal to the absolute value of a, 3 times -1, plus b, which is 4 times y, which is -1, minus 8, all over the square root of a squared. A squared is 9. B squared is 16. So I'm going to get -3 plus -4 plus -8, the absolute value of -15 over the square root of 25. The absolute value of -15 is going to be 15. The square root of 25 is 5. Therefore, the distance is 3 units. And the formula is much easier to use than taking that long, involved process. So there's the formula. I won't be giving that to you. I expect you to know that formula. Okay? Number 19, I have points A, B, and C. So I'm asked to plot those points. -3, -4. So there's the point A. 5, 4. There's the point B. And then C at 5, -4. Which is right here, C. So I should recognize pretty quickly I have a right triangle. If I have a right triangle, the coordinates of the circumcenter, remember in a right triangle, the circumcenter is equal distance from 3 vertices, A, B, and C. So therefore, it's the midpoint of line AB. So I need to find the midpoint of AB, which is the hypotenuse. So here I have -3 plus 5 over 2 and -4 plus 4 over 2, which is going to give me a midpoint of 2 over 2, which is 1, 0 over 2, which is 0. So the midpoint is going to be here at 1, 0. So the answer to this question is 1, 0. And it asks for the radius of the circumscribed circle. Remember, the circumcenter is the center of the circumscribed circle. So therefore, the radius is from the circumcenter to any one of the vertices. You can use whichever one you choose. I'll use B. So the radius r is equal to that distance, which is the square root of this point D in the middle, call that D, to one of the vertices. I'm going to choose B. So 1 minus 5 squared plus 0 minus 4 squared. That's going to give me negative 4 squared, which is 16, plus negative 4 squared, which is 16. It's going to give me the square root of 32, which is 4 root 2. You can go ahead and put that in decimal form if you would like. Now, C is the last question. Don't be fooled by this. You're simply asked to find the equation of the perpendicular bisector of AC. So here's AC. The perpendicular bisector occurs at that midpoint. So the midpoint of AC is going to be minus 3 plus 5 over 2 and minus 4 over 2. It's the equation, it should be the equation of x equals 1 when I'm looking at AC. Should be that equation. There shouldn't be any change in the y-coordinate. Should just be at x equals 1 because it's perpendicular to a vertical or a horizontal line. So x equals 1 for letter C. Number 20 asks you to find the midpoints of the sides of the triangle, and this is probably the hardest question on the test. So let's take a look at this, and then I've actually added another one. We'll take a look at a second problem like this. So I have a point R at minus 2, minus 3, right here. I have a point A at 0, 4, right here, and a point T at 3, 2, right here. These are the mid-segments of a triangle, and I am looking for the vertices of that triangle, and I have to figure out where they are. Okay. So now when I look at this picture, I can look at the slope. Let me label these. R was here, A is here, and T is here. So I want to look at the slope of RT. The slope of RT. So I have minus 3 minus 2 over minus 2 minus 3. Oh, that's minus 3 minus negative 2, which makes it plus, which means I have minus 1 over minus 5, which is 1/5. So I have a slope of 1 over 5. So now I want to construct the segment that is parallel to RT and twice its length and passes through the point A. So go to point A. Point A is at 0, 4. And now I'm going to add 5 units to the x-coordinate. And I'm going to add 1 unit to the y. Okay, so from A, adding 5 to x is going to give me 5, 1 to the y is going to give me 5. So I have this point at 5, 5. 1, 2, 3. Here it is, 5, 5. Then I'm going to go back to A again. And this time I'm going to subtract. So go to A again. This time subtract 5 units from X and subtract 1 unit from Y. So I'm going to go from 0 to -5 and from 4 to 3. So at -5, 1, 2, 3, 4, 5, 1, 2, 3 is my next coordinate. If I draw that line, let's call that EF. EF is now parallel to RT and twice its length. I'm going to repeat that process for one of the other sides. Let's choose this time the slope of AT. The slope of AT. So I have 4 minus -2, which is going to be plus, then 0 minus 3. So I have 6 over -3. That's the slope of AT. So now I'm going to go to the point opposite that side. So I'm going to go to point R. R is at -2, -3. So from point R, I'm going to add 3 units to the X coordinate, and I'm going to add 6 units to the Y. So adding 3 units to the X is going to put me at 1. Adding 6 units, so I'm actually going to add that so that it's going to go further down when I'm adding it. I'm actually going this way. So I'm actually, I guess I'm going to say I'm going to subtract 6 units. You have to use the graph. This is a very visual process. So I'm going to be at 1 minus 9. Remember, when you're looking at this slope, you have this slope of AT. You want to be parallel to that and twice its length. So I'm going to go to 1 minus 9 right here. And if I draw this line, I should be able to connect E to this new point, call it H. And then if I draw the line connecting F and H, I should be able to complete that triangle and pass through that point. So the coordinates of E, F, and H are going to be at 5, 5, -5, 3, and 1 minus 9. 1 minus 9. And that's a difficult problem. You're just using the slope and applying the principle that that mid-segment is parallel to and half the length of the third side. Okay, let's go on to the last problem. Given D is the centroid of ABC, remember the distance from the centroid to the vertex is 2/3 the length of the median. So from the centroid to the vertex is 2/3 the length of the median. The median in this case is BE, okay? So BD is equal to 2/3 of BE. So therefore, DE is equal to 1/3 of BE. So you should get that BD is equal to 42 and DE is equal to 21. If AE is 13, BG is 9.5, you know G's a midpoint. You're also told it's isosceles, so you know that each of these are also 9.5. E's a midpoint, that's 13. Therefore, the perimeter is equal to 64. And that pretty much encompasses the quiz for tomorrow. So if you did very well on this review sheet, you'll do probably very well tomorrow. Take a few minutes to review, and I'll see you tomorrow. Have a nice evening.